Good morning, everyone. Welcome to the demo on ethical hacking. I'll be your trainer for this day. So, to talk a little bit about myself, I have done my MTech in cyber forensic and information security. I have done my UG degree in computer science. And also, I've done international certifications like Certified Ethical Hacker. I'm a certified trainer for the EC Council, as well as I've completed EC Council Certified Security Analyst. Along with these EC Council certifications, I have also done my ISO certification 27001 2013, and also I have done certifications on Cyber Forensic Associate as well as Microsoft Security Basic Fundamentals certifications. I have 15 plus years of experience in the IT industry, in which 7 plus years of experience in cybersecurity domain. After completing my post graduation in cyber forensic, I've been working in this cybersecurity field. So, in the cybersecurity field, I've been working in different domains like penetration testing, consulting, as well as training. So, I've been in the training field for more than 7 years, and I've trained more than 100 batches now on different courses like ethical hacking, penetration testing, security analyst, security plus certifications, as well as I have experience in delivering the cyber awareness training, and I've also experience on writing customized courses on cybersecurity. The scope for this demo, I have taken a topic on sniffing. So in this particular demo, we will be talking about what is sniffing, and we will discuss about the working of ARP and the CAM tables, which is required for the normal working of a switch. And I will be discussing about some of the attacks like MAC flooding attack, ARP spoofing attack. ARP stands for Address Resolution Protocol. So Address Resolution Protocol spoofing and poisoning attacks, and man in the middle attack. Finally, I'll conclude this demo with the countermeasures how to prevent this particular attack from happening. The course we are discussing right now is a course on ethical hacking, and it has got 20 modules. So we will be covering different topics, which includes introduction to information security, and we will discuss about hacking and the different phases of hacking like footprinting and reconnaissance, network scanning, enumeration, gaining access, clearing tracks. These are the 5 phases of hacking. So we will be discussing all these phases in detail. Along with that, we will be covering the different security domains like network security, application security, cloud security, IoT, and also mobile and wireless platform. How the attacks happen in these platforms, as well as how to effectively prevent them. We also will discuss about the cryptography technique, as well as the other security controls like firewalls, IDS, and antivirus. So this will be our course outline for the ethical hacking course. It includes 20 modules covering various practical labs, as well as the controls that are effectively used to manage and protect from cyber attacks. So let us get back into the topic for the day, that is sniffing. What is sniffing? Sniffing is monitoring and intercepting the traffic between any two computers or any two devices which are connected in the network. The basic idea here is an attacker will try to intercept between the two victims, or we can say two devices which are on the same network or which are on the different network, and he will try to monitor the traffic between them and try to gather some potential details like, or sensitive details like credentials or cookies or well as session IDs, etc. So he will try to capture some information which will help him in the further attacks. Usually, attacker places a sniffer, it can be a hardware or a software device, in order to intercept the traffic and to steal or modify the data between them. So when we talk about a sniffer, this particular sniffer, it can be a hardware or it can be a software. It works in the layer 2 of the OSI model. If you are aware of the network models, OSI or Open System Interconnect is the reference model for the any working of the networks. if you want to understand the working of the networks, you have to understand the OSI model, Open System Interconnect model. This model has 7 layers. So this sniffer works at the second layer, that is called as the data link layer, where MAC addresses are used to uniquely identify between the computers. We don't use a public IP address over here. This works within a local area network. So sniffers operate at the layer 2. This is very important to remember, so that it will be like easy for us to understand in the coming slides. Basically, there are two types of sniffing depending upon how you do it. One is passive sniffing and the other one is active sniffing. What is passive sniffing? Passive sniffing is the attacker or the person who is trying to intercept the communication. He doesn't do anything actively. He doesn't try to connect, he or she doesn't try to connect with the target directly. Instead, he just listens to the traffic. How is it possible? So attacker tries to connect himself with the network. Say for example, this is a switch. My drawing is not very neat. Please excuse me for that. So if the switch, there are connected different computers. In the case of passive sniffing, this will be a hub. This will not be a switch. This will be a hub. Hub is a broadcasting device. So what happens with hub is, one is passive sniffing, another is active sniffing. In the passive sniffing, the attacker does not do anything or does not directly communicate with any of the devices. He just listens. He or she just sits in the network and listens. So how does it happen? Hub will be the device which is connecting the other computers and other networking devices here. This hub is a broadcasting device. That means, what does it mean? Hub, whatever the packet that comes or that passes through the hub, automatically it will be sent to all the devices which are connected to it. Say for example, right now, so this is the hub, and there will be ports on the hub where the different computers will be connected. Say for example, this is one computer, this is one, this is a mobile device, this is another networking device. So there are different devices which are connected to the hub. Okay, so hub is a broadcasting device. What does it mean? Any packet that is coming from any device. Say for example, this computer A is sending a packet to device B. So this packet goes through the hub. When it reaches the hub automatically sends it to all the devices which are connected to the hub. What happens, what is expected to happen is, only B should respond to this because it is intended only for B. All the other devices will neglect it, will not consider that particular information. But if these devices, one of these devices is an attacker, what he does is, say for example, this is an attacker. He just connects himself to the hub, and he waits there for the hub to transmit the packets to all the devices. So he will just getting connected to the hub, he will be able to receive all the packets that are passing through the hub without having to do any kind of attack, without having to intercept, or without having to put any active effort, without doing anything, just being passive in that network. He will be able to listen to all the traffic that is passing through the hub. This is called as passive sniffing. In active sniffing, what happens is, the connecting device or the device which is used here to connect the other devices will be switch. Switch, unlike hub is a broadcasting device, but switch is a point-to-point device, P2P device. So what is point to point? If you want, if say for example, there are a lot of devices which are connected to the switch here, switch ports here. So if A wants to send a message to B, the switch will only send that packet to B. It will not send that packet to anyone else. So in this case, if the attacker wants to place a sniffer and wants to intercept the traffic between A and B, he has to connect himself to the switch first. This is the attacker. We will name him as AT. This attacker has to connect himself to the switch, and then he has to do a attack. Say for example a MAC flooding attack, or he has to do a ARP poisoning attack. I'll explain in the next slide, coming slides, what is ARP poisoning and all, MAC flooding and all. So he has to do something in order to intercept the traffic and redirect the traffic to himself. So this is called as active sniffing, because in active sniffing the attacker have to do something in order to intercept the traffic that is going between two devices. So these are the two types of sniffing. So you can see here how the switch works. Switch is there. The attacker connects to the switch in Prometheus mode. He puts the sniffer in Prometheus mode. The common sniffer tools are Wireshark. You can use a Wireshark or you can use a Cain and Abel tool. So these tools will act as a sniffer in the layer 2. And whenever the switch tries to communicate between two devices, the attacker will intercept the traffic. He can modify, steal, or he can manipulate the traffic going between two devices. So this is a Wireshark tool. I've just put a screenshot for our understanding. Wireshark is called as a packet analyzer or a protocol analyzer. The basic functionality of Wireshark is to capture the traffic, and then we can analyze the traffic to see what is the statistic, like how many protocols are involved in this particular traffic, how many TCP packets, how many UDP packets, which all IP addresses were involved. We can do a detailed analysis using Wireshark. But Wireshark can also be used as a sniffer. Basically, it captures the traffic, so the attacker can use a Wireshark as a sniffer also. Okay, so in order to understand the process of the ARP poisoning, we have to understand how the CAM and ARP table works. First, let me say what is ARP table. ARP table is called as address resolution table or address resolution protocol. ARP is a protocol, network protocol, which is called as address resolution protocol, which is used to translate between the IP address and the MAC address. As we know, inside a network, there will be two addresses which will address a particular machine. A MAC address will be there and an IP address will be there. MAC address will uniquely identify any device. MAC address is a 48-bit address. First 24-bit will go to identify the manufacturer. Next 24-bit will identify uniquely that particular machine. The IP address that we use here will be a private IP address to be used within the local area network, because the machines does not use the MAC address for communication. So this IP addresses will be used for the communication between them. So somebody has to translate between the IP address and MAC address, because every device is uniquely identified by the MAC. So this ARP table does this job. So whenever there is a communication coming in for a particular computer with its IP address, immediately the switch will look into the ARP table in order to find the corresponding MAC address. So now the MAC address is found. But how do we find where it is connected? So again, let me put this way. There is from outside, there is a packet coming. This is the network and this is the switch, and there are devices connected to it. Every device is having a IP and MAC. These IPs can change because if they are allocated by the DHCP protocol, dynamical allocated protocol, then the IP will differ, but MAC will remain same. So we use MAC to identify the. So every device will have one IP address and one MAC address. Say for example, from outside there is a packet coming, and here there is another process to convert from public to private IP addresses that will be done by NAT. If you know the basics of network, you will know all this stuff. NAT is Network Address Translator Protocol, which translates from public IP address to private IP address, because in internet we use public addressing, within the local network we use private addressing. So NAT will convert between the public to private IP address. Now when it comes to switch, it will have a IP. So now the switch should know where exactly to send the data. So what will happen? It will look into the ARP table. This ARP table will contain IP to MAC translation. So it will take the IP and see which MAC it is. Now you know where is the which MAC, but you should know which port that particular system is connected to. Now 4 ports are there. Now I know the MAC, but I want to know where exactly that computer is connected. Then only the switch can send the data to that port. For that, we use another table called CAM table. This CAM table will have the data of MAC and port number. Port number. So when the packet comes in with the IP, the switch will look into the CAM table, look into the ARP table to identify the MAC address corresponding to the IP address. Then it will go to the CAM table and it will see the MAC address and find out corresponding port number. And depending upon the port number, if port number is 2, then it will send to the second port. The data will be sent to the port number 2 where that particular destination is located. So this is CAM table. CAM table contains the entries between translation between MAC to port number. ARP table contains the translation between domain to private IP address to MAC address. So in the diagram, what you're seeing here is a CAM table. So this is a CAM table here. You can see that MAC address and port number is there. So for the very first time when a device gets connected to the switch will not know the MAC address, right? So for the very first time, this is little like a network topic. You have to little bit understand this topic. So that's why I'm explaining this. So here the switch is there. So computers are here. So for the very first time, a computer, say for example, A is trying to get connected to the switch. Even to communicate between the local area network. Now all of them are in the same network, right? All of them are in the same network. So in order to communicate between the network, what happens is that in order to do that, they also use the ARP table and the CAM table for their communication. Every device inside the network will have its own ARP cache table. They will use the ARP cache table in order to communicate between the devices. So what will happen? Very first time any device wants to connect with the switch will not know the IP or MAC address and the port number of A. So what it will do, it will send a broadcasting data packet to all the devices asking for this particular IP address. Say for example, from outside, a packet has come to A. It will go to switch and the switch will look into the ARP table. The ARP table does not contain any detail about A because A is a fresh device which is just connected to the switch. So the switch will not have the details of A. So what will that switch do? Switch will send a broadcasting request to every device connected on that particular network asking who is A. Who is this particular IP address? So all the devices will receive that particular request and only that particular device which is that having that IP address will respond with its MAC. It will say, I am A and MAC is, and it will give the MAC of A, that is its own MAC address it will give. So immediately the moment the switch receives this reply, it will update the ARP table with the IP address and with the MAC address. And from which port number that reply arrives, it will update the CAM table also with the MAC address and port number. This particular MAC address is located at this particular port number. For further communications, now we can use the ARP table because ARP table and CAM table are both updated with the data of A. So this is how a switch works. So you can see here. So when the switch does not have the data, it will ask the computer, all the computers, it will ask who is having 192.168.1.3. Please tell to this particular device. It happens with the other devices also. Say for example, I have 2 devices in the same network. This particular device A wants to communicate with B and A looks into the ARP cache in order to find out whether it has the details of B. But if it doesn't find the details of B, it will send a broadcasting request to all the other devices connected on the switch. So you can see the broadcasting request going to all the devices. Who's having this 192.168.1.3? Please tell to this machine. So only that particular device which is having that 192.168.1.3 IP address will respond with its MAC address. You can see B is having 192.168.1.3 IP address and it is responding with the MAC address. Then immediately the ARP cache and the ARP tables will be updated with the details that are received from the target. Okay, so I will show you the CAM table here. ARP table here. So if you go to command prompt, just give ARP minus A. It will show you the ARP table. You can see that IP address and corresponding MAC address. This is what I was saying. So when this computer wants to communicate with any other computer, immediately it will look into its ARP and find the IP address corresponding MAC address. It will go to the CAM table. CAM table, it will find the MAC address and corresponding port number. Then it will send the data to it. That is how the communication behind the network happens. But how does the ARP attack happens? How does an attacker takes advantage of this mechanism? So let's see that. As I told you, CAM table contains the translation between the MAC address and the port number and other VLAN parameters. Right now, we will leave that VLAN parameters that is not required for us, but let us concentrate on MAC to port number. So this is the ARP table. You can see the IP addresses with their corresponding MAC addresses, and CAM table contains the details between MAC address to port number. This is the CAM table. So you can see that the details of MAC address to port number is located. Now, as I told you, in order to do an attack, the attacker has to do some kind of effort, or he should take some effort in order to intercept the traffic between any two devices connected on the network. The first thing he can do is a MAC flooding attack. This CAM table contains the translation between MAC address and port number. It is a very small dynamic memory and it can be easily overloaded with spoofed data or with fake entries. It can be easily overloaded. Just imagine this situation. There is a very small table and you are the attacker and you are trying to flood the table with fake entries. So what will happen? You are just flooding the table with, say for example, you are saying that computer A has this MAC address. You are sending the same reply, same translation between computer A's IP address and MAC address, but with different MAC address, same IP address, you are sending fake replies. Thousands and thousands of fake replies you are overloading that CAM table with. So that the CAM table will keep on updating its entries. It will keep on updating MAC A. System A is located at this MAC address. IP address A is located at this MAC address. The MAC address will be continuously changing because you are sending fake replies to that machine. At one particular point of time, what happens is that the CAM will get over flooded, overwhelmed with the responses it is receiving, and it will stop functioning. At that particular point of time, switch will have no other option because it cannot access the CAM table. CAM table stopped functioning. Now it cannot access the CAM table. That means that it cannot locate where exactly that computer is located, which particular port number that computer is located. Because it is not able to understand where it is located, it will send the data to all the other machine. It will just act like an hub. It will become in a broadcasting mode. It will turn into a broadcasting mode. It will send the data to everyone in the sense now the attacker is also in the network. Because the switch starts sending the data to everyone, the attacker also will receive the data. This is called MAC flooding. To explain it, we have a very simple tool called MACoff. I will explain that. I'll show you that. So I'm using Kali operating system for that purpose. Let us switch on this Kali operating system. Okay, it will taking some time. Let us move ahead with the next topic. I'll show you this once it is up. The second attack that we can do is a ARP spoofing attack. As I explained to you earlier, when a new device gets connected to the network, the switch does not have any idea about what the MAC address, what is the port number, and the details of that particular new computer. So immediately it will send a broadcast request to everyone on the network asking for this particular IP address. Who is having this IP address? Please send the response to the switch back. So the attacker is also sitting here. Before the target could respond with the MAC address, say for example, B is the target address for which switch is looking for the, so it is asking B's IP address and it is asking for the B's MAC address. Before B could respond, the attacker will respond saying I am B and my MAC is at this particular location. He will not send that response once. He will continuously be sending that reply again to the switch. By mistake, if the switch accepts the reply from the attacker, what will happen? The switch will update the ARP table with the details of attacker. Okay. So here you can see there are three machines here: machine A, machine B, and machine C. Machine A, machine B, and machine C. So the IP address is also given there: 1.2, 1.3, and 1.4. Say for example, the switch is asking for 1.3. 1.3 is located at BBBBBB, that is the MAC address of 1.3, and switch is looking for the MAC address of 1.3. So it sends a broadcasting request to everybody on the network. It will ask who is having 192.168.1.3, please respond. Who has to respond? B has to respond. Before B could send a response, the attacker C, he will send a response saying I am 192.168.1.3 and my MAC ID is CCCCCCCC. If the switch accepts the request from the attacker, so what does the ARP table look like? ARP table will look like IP address 192.168.1.3, MAC address CCCC. That is attacker's MAC address. But the MAC address belonging to B will be BBBB, right? So instead of updating it with BB, it will be updating it with the attacker's MAC address. So the attacker will be receiving the data. Whatever data being sent to this particular IP address 192.168.1.3, all the data will go to the attacker because the MAC address is the uniquely identifying address here. Every device on the network is identified using the MAC address. Because the MAC address belongs to the attacker, whatever data sent to 192.168.1.3 will go to the attacker instead. So the attacker will keep a copy and forward a copy to 1.3 also, so that he will not be become suspicious in the network. Nobody will suspect him for this particular crime. He will forward that, but he will take the data also that is coming inside. Let us see this particular attack. I will explain to you using a tool here. So this tool name is Cain and Abel. This tool has various functions, but we will use the ARP poisoning tool here. So this is a sniffer. Just like I said, sniffer is used to capture the traffic. First, you have to activate the sniffer. Before going to that, let us select three machines so that we can understand the attack better. The first machine will be my Windows 10 machine. Let us note down its IP address and MAC address. And the target machine will be my Linux machine, that is victim 2, victim 1, and attacker will be my Windows 7. So here you can see Windows 10's IP address is 1.42, and Windows 7's IP address is 1.35, and Linux machines is 1.37. So let us note down. This is a ARP table. You can see that 1.35 is at this particular MAC address. 1.37 is at this MAC address, right? So we will note down this. 1.37 is at this MAC address and 1.35 is in this MAC address. Okay. And 1.42, that is my Windows 10. Windows 10 is at 74 DFBF. I cannot copy it, so just I'll write it here, 74 DFBF, in that range. Okay, now this is the original values, right? These are the original data, or these are the data that belongs to this computers. Windows 10 is at 1.42 and its MAC address is this one, and the Linux is at 1.37 and the MAC address is this one. Windows 7 is 1.35, MAC address is this one. So when a ARP poisoning happens, what exactly happens is this particular attacker in the ARP table replaces the MAC address of victim 1 and victim 2 with the MAC address of the attacker. That is, he will overwrite his MAC address on for both the victim 1 and victim 2 in the ARP table. So what will happen when he overwrites his MAC address on the top of the victim's MAC addresses? Whenever there is a communication happens, whenever somebody wants to send data to victim 1 or victim 2, they will go to the attacker because the MAC address in the ARP table belongs to the attacker. So let's see how it happens. Let us go back to our tool, Cain and Abel tool. First, we have to activate the sniffer. And once we activate the sniffer, we will go to the host in order to find out how many computers are connected in the network. So I'm scanning all the hosts in my network. So I will know all the devices which are currently connected to my network. So these are all the devices which are connected to my network. Right now, I am the attacker. My IP address is 1.42. So the attacker's IP address is 1.35. And there are other machines like 1.42, 37 and 44. So now what will I do? I have to choose two targets. So I will become man in the middle, right? I can do a ARP spoofing and attack, and I can become a man in the middle person, so that I can listen both the traffic. So I will choose two victims in order to do the man in the middle attack. So in this case, I will choose two victims according to our notepad. The victim 1 is 37, victim 2 is 42. So let's select victims, victim 1 and victim 2. Okay. So and you can see that here it is selected. These two are victims. Now I will do a ARP poisoning. What is ARP poisoning? That is, whenever there is a communication happens, the device will ask for the MAC address of the other device. That is, 37 will ask for the MAC address of 42, and 42 in turn will ask for the MAC address of 37 for the communication to happen. For the very first time, they both are communicating with each other. So they will ask for the MAC address of both. So when they are asking for the MAC address, the attacker will get in between and send his MAC address as the reply. He will try to overwrite the ARP table of 37 and 42 with his own MAC address. That is what he will do. Let us poison this. The moment you poison this, it's poisoning. Go back to the victim's computers, and if you do ARP, you can see that the data has been changed. You can see that here the MAC address have been changed to attacker's MAC address. Initially, you can see here in the previous ARP, 1.35 was at 9F and 1.37 was at E401. But now what has happened after the ARP poisoning, you can see that both the MAC address are reflecting the MAC address of both the MAC address are reflecting the MAC address of the attacker. 9F. 9F belongs to attacker. You can see in this 9F belongs to the attacker. Okay. In the same way, you can go to the other machine, the Linux machine. Now you say ARP minus A. You can see that 42 and 42, that is your Windows 10 machine. Previously it was 74 DFBF. You can just see the previous command. It says that 74 DFBF 7F DB is the MAC address of 42. Now 42 is reflecting 080027D5A3 9F, which belongs to the attacker. Right? So now both the tables are modified. Both the tables are overwritten with MAC address of attacker. Now the communication between these two computers, that is victim 1 and victim 2, it can be sniffed by the attacker. The traffic can be captured by the attacker. So let's see that. So when this is victim 1, victim 1 is doing a FTP transaction to victim 2, 192.168.1.30 right? Our victim Linux machine. Linux machine is at 1.37. So it is coming. It has no idea that the attacker has overwritten the content. We won't verify the ARP table every time, right? So it has no idea that the attacker has modified the ARP table. So when it does the FTP, usually the FTP communication starts and it will give the username and password, and it is login is successful. It does not know there is an attacker sitting in between listening all the conversations. So when he is doing that, go back to the attacker. You can see that the attacker would have captured the data. There are some previous entries. Let me remove all. Let me go back here and do the transaction again. So you can see that it is logged in and the login details are captured by the attacker. You can see that 192.168.1.37 was communicating with 1.42 and the username is msfadmin and password is msfadmin. So in the same way, it can capture all these protocols. All these protocols are called as clear text protocol. That means that there is no encryption enabled for them because the attacker is now able to intercept the traffic, whichever clear text protocols are passing. Otherwise, if it is HTTPS or if it is SSH and all, they are encrypted protocol. Even if the attacker is able to capture the traffic will be in a encrypted format. But these protocols are clear text protocol. That means that whatever goes through these protocols are unencrypted. He can read them directly, just like how you are able to read this transaction. This is a captured transaction. You are able to see the username and password directly. So these two are the victims. You can see that these two are the victims. So whatever goes between the victims, the attacker is able to capture. If any, let us see for an HTTP transaction. Let us go ahead with an HTTP transaction. There is an application running on that machine 37. So I am using the login screen here. I have logged in. Now go to the attacker machine. You can see that 27.4 new entry, and you can see that the username and password is captured over here. 1.37, 1.42, this is captured. So this means that the attacker has now become the man in the middle. He is able to see the communication that is happening between the two victims and he is able to intercept them. So this attack is called as ARP poisoning attack as well as man in the middle attack. Using ARP poisoning, we have done man in the middle attack. So this is an sniffing attack where we use the sniffers. Even you can use a Wireshark in order to do that. So let me show that Wireshark also quickly. So you can see how the communication happens. Because four concurrent machines are running, it is little slightly slow here. Let me put off the sniffer also. Sniffing and spoofing, you have many tools. One of them is Wireshark. So any time when the systems are wants to communicate with each other, you can see that that particular broadcast request you can see here. Who's 192.168.1.44? Please tell to 192.168.1.37. Immediately 1.44 responds with the MAC address 080027C50D1C. So this is the initial process. From the initial process, the attacker takes advantage of this process and inserts his MAC address in the place of victim's MAC address. So the moment you do the ARP poisoning, the ARP table changes, right? The ARP table changed. Now because we have switched off the poisoning, you can see that the ARP table would be restored back to the original values. You can see here the ARP table is restored back to the original values. So this is ARP attack and man in the middle attack. These are the protocols which are vulnerable. There are many other protocols, but most importantly, these protocols are vulnerable: HTTP, FTP, POP3, IMAP, Telnet, SNMP, SMTP. So this is man in the middle attack. What I showed you, there are two victims. The attacker manipulated the ARP entries in both the victims and overwritten with his MAC address. So when they want to communicate, instead the traffic goes to the attacker instead. So the attacker is able to receive the traffic. What are the preventive measures? The first thing is like you have to use a secure protocol. That means every place possible, instead of HTTP go for HTTPS, instead of FTP go for secure FTP, instead of telnet go for SSH. So wherever it is possible, go for the secure protocols and use strong authentication method. Instead of just using a username or password, use two-factor authentication or biometric controls. Use encryption to protect all your data. Use VPN when you are trying to connect to the remote machines. Don't download from the internet like the free softwares, or use some strong controls like IDS, monitoring devices, antivirus, things like that. So this will help us to prevent against the ARP poisoning attack. You can also install something called as XARP. XARP is a tool which will generate an alert whenever there is a MAC change is happening. Whenever the MAC address is trying to be overwritten, immediately it will give a alert to the administrator. That can also be used. Other thing is enabling the port security. What is port security? Whenever the port security is applied on the switch, so whenever there is for one IP, two MAC addresses are coming. Like in this case, the victim's IP addresses and MAC addresses, the MAC address is tried to overwhelmed or overwritten with attacker's MAC address. No, that means that one IP address at one point of time there are two MAC address, one genuine MAC address and one was attacker's MAC address. Whenever there is a situation arises like this, when the MAC address, there are two MAC addresses for one IP address, immediately this particular overwriting or this particular change will be noted as suspicious and alarm will be generated. This will not be allowed on the switch. So these methods can the prevent the networks from having this ARP poisoning attacks, man in the middle attacks. So that's about my topic for today. So the add-on topics for this particular topic can be network security, penetration testing on networks, port security, and network zoning. How to zone our network, how to divide our network into multiple secure zones, and how to protect them using various controls. So that is another topic. So here we can assign projects like find the loopholes in the network and try to do a ARP poisoning attack, and sniffing into the network and generating a report of all the protocols, all the traffic, and trying to identify the credentials of the logged in sessions using Kane and Able tool. This projects can be completed at the student side and can be presented back to me. So we will be providing you the list of IP addresses and things like that, and the list of computers. So you can try to do a project at your own end and submit the report. So this has to be completed by the student using the same tool, Kane and Able, and like just like how we discussed right now, you try to do a ARP poisoning attack between two target devices and try to raise the traffic, and through that traffic capture the credential and present it as a report. For this, you need the lab setup. As a part of lab setup, you need the virtual box. You need three operating systems. So you can use a Kali operating system, Windows operating system, a Linux machine. You need a Kane and Able installed operating system. So Kane and Able is a Windows based tool. You can install it on Windows 7 or Windows 10. One suggestion from my side is whenever you are using a tool on ethical hacking tool, whenever you want to install a hacking tool, do it on the virtual machine. So if at all there are some kind of like backlash or anything happens, it will not come to the main machine. So use it on only on the virtual machine. Install your hacking tools only on the virtual machine. So you can install a Windows operating system in the virtual machine and install Kane and Able tool over there. Bring 3 or 4 computers in the same network, and using Kane and Able tool, try to do a ARP poisoning attack and capture the credentials. So for this, you need this particular lab setup. You have to install the virtual box. Inside the virtual box, you have to install all this operating system. Bridge this computer so all of them come into the same network. They all should belong to the same network. So how do you identify they belong to the same network? Using the IP address. So when you bridge the connections, when you check the IP addresses, it will be in the same range, like 192.168.1.42, 192.168.1.43. The network part of it will remain the same, 192.168.1. That is the network part for class C addresses, that will remain the same. So you can verify whether all your computers, all the operating systems are in the same network. Then you can try. Why in the same network? Because sniffer operates only at the data link layer. It does not operate on the above layers. So we will be providing the PPTs of this particular topic and also the PDF documents and references, web references, giving you more details on sniffing, ARP poisoning, as well as port security tools. You can download them. We will be uploading them in the Teams or in the server. You can download them from there and install them in your lab setup. So the certifications that are available in this particular course related like in the cybersecurity as well as in the market right now, which are most wanted, which will give you a very good opportunity in the job market. They are CEH Certified Ethical Hacker, ECSA, that is EC Council Certified Security Analyst, EHA, that is a beginner course on ethical hacking, Security Plus Certification, CISP, CISP is Certified Information Security Professional, then CCNA is completely on network. All these certificates are considered to be the best certificates in the market, and there are a lot of job opportunities for those who have completed these certifications. So if you are interested in ethical hacking, these certificates will add value to your resume. Thank you for listening to me patiently and cooperating with me. Please share your feedback. Thank you.